Hello everyone, welcome to my YouTube channel 0 to 1. This is Rishu this side, and this is our development series where we will try to learn different backend core concepts and build projects around them and learn how they are implemented. So nowadays, whenever you go for SD1 or SD2 jobs, generally people used to ask different kinds of components, how they are used and why they are used. So the motive of this playlist would be not just to know why things are used, but also to understand how they are built and how they are implemented. So the topic for today is we will understand how we can build a load balancer and what is a load balancer. So let's get started. So first of all, we will talk about what is a load balancer. So a load balancer is like a device that sits between a client and the server. And the main purpose of a load balancer is to direct traffics equally so that the resource utilization of the system remains equal throughout all the servers and just not one server gets choked up. So a load balancer is basically, you can say, it's an agent between a client and a server that sees that how the requests are served. I mean how the requests are served quickly and efficiently. So let me start with what is a load balancer. So as I said, it is a device that sits between user and server and act as an invisible facilitator, ensuring that all the resources are used equally. So what we mean is that, let's suppose this is our load balancer and this is our backend server basically, and where our services are deployed. This is one, this is backend server 2, this is our backend server 3, and this is our user 1, this is our user 2, and then this is our user 3. So all these users will go ahead, and whenever they do a request, this request goes to load balancer, and it is let's say this is request 1, this is request 2, this is request 3, and it is the job of a load balancer to actually go ahead and distribute these requests so that every request gets, so that they have a very quick response time. So the work of load balancer is to redirect request 1 here, or redirect request 3 here, and then again request 2 can be directed here or here, as it depends on the availability of the server, that which server is available right now. So this is a basic functionality of a load balancer. When we talk about a load balancer in a HLD system, it sits between the user and the backend servers. So what are the key points of a load balancer? So first of all, a load balancer is necessary when you have more than one server. This means that if you have more than one servers where your backend services are running, then definitely one server, if you are having more than one server, there should be a mechanism to redirect all the requests so that each and every server is utilized. So whenever you have more than one server, you will definitely need a load balancer. Secondly, a load balancer can also act as a reverse proxy. When I say reverse proxy, this means the user is not actually going ahead and doing the request on the load balance on the backend service. It is rather going ahead and doing it on the load balancer level, and our backend services remains hidden from the user. So this can act as a proxy where our backend services are hidden and they are not visible to the client. The third is that the load balancer helps in prevention of DDoS attacks. So DDoS attacks, it literally means deliberate denial of, it's a deliberate denial of service. It's a deliberate denial of service attack. So in this attack, what happens is that a user or a client sends multiple requests to a server in hope to choke a server and make the service down. So this load balancer takes care that and does not sends every request to one backend service, rather than it sends it to different backend servers so that the load is distributed efficiently and the servers don't go down. And fourth is a load balancer decreases response time and decreases latency as well. So when a load balancer is there, there is equal utilization of resources. So when every server is equally utilized and none of the servers are receive too much traffic other than the other, so we definitely increase the user experience and we also decrease the latency. It also it also helps in keeping the health check of the system. So a load balancer can also be a gatekeeper of your system. So whenever a server can go down or a server can go up or a multiple servers can go down, a load balancer has that capability that it can only direct the request to healthy servers. So it can also act as a service health checker who constantly keeps a check on whether the servers are responding or the servers are dead or not. And it can actually be a resource manager at that time. And a load balancer also helps in maintaining the security of a system. So with a security of a system, you can have a load balancer configured with firewall, with securities to with you can also have your load balancer deployed having multiple security patches which can actually detect malicious requests and they cannot serve them and they will not serve them. So in this way you can have a security at a load balancer level as well. So these are all the benefits that a load balancer serves, and this is definitely a very important topic when we talk about the concepts of HLD. Whenever you go in a HLD design discussion, uh, whenever you think about scaling your system from 1 to million users, or whenever there are multiple microservices, load balancer are a very important component that you must consider. So without doing further ado, it's time to build. So everyone must be thinking about, okay, all these are the benefits of load balancer, but how can we build them? So in this video, our main purpose is to learn how a load balancer is built, how we use them, and how we can run them locally as well. So it will be a kind of mini project where you can learn how these things work. So in this video, we will basically cover just the first topic. We will run how to run a basic server that can listen to HTTP request, and post that in next video, I'll try to I'll try to teach you how we can create multiple local servers and other stuff. So without doing further ado, let's get started. So I would be using Python for this purpose because Python has inbuilt libraries and other stuff that will make the process easier. But feel free to use any language because this is going to be an totally language agnostic thing. You can use any language of your choice to make this happen. But I'll be choosing Python because I'm also comfortable and the libraries are readily available here. So first of all, our task would be to start a basic local server that would respond to requests, and we will bind it to a port. So port is basically an endpoint where the requests come and a backend server responds to that port. So we can start by making our main function. So this is how we define our main function in Python. So this will be our main function. Post that we can have our function that will be start backend server. So we will need to pass in the port at which we want to start the backend server. So I'll go ahead and take a port at 8081 and we can start that server at this port. So going ahead, we would need this complete function that would take in a port, and then we can start our development. Okay, cool. So this will be our start backend server. So first we need to create a TCP IP socket. So what a socket is basically an endpoint in a bidirectional communication. So that basically there can be a client socket as well as a server socket. So the sockets basically represent an endpoint where a client needs to request and where a server needs to send it data back so that the communication is maintained. So there will be two sockets basically in a networking system when people will communicate. So we can go ahead and create this socket. So for this I would need a socket library. So this is actually available in Python. In other languages, please feel free to explore the libraries, but for Python, this is the library which you can use. If you want to use Python, you can go ahead and use this library. So with socket.socket, so this is AFI is address of internet where the communication will take place, and this sock stream will create a streaming kind of object where we can have a bidirectional communication, as this will be our socket for server where we will listen to the requests. Now since our socket has been created, we need to bind this socket. So for binding, we need to bind the socket to a port at which our uh, web server is running. So we will use server socket. Let's rename at server socket. So with server socket dot bind, I would go ahead, and since we are running it locally, so the name of our host will be localhost, and it will be bound to our port, whichever port we pass in. So next will be we will listen to the server. So for listen for incoming requests, so that is our next task. So for listening, we would do server socket dot listen. So our server would start listening to this port. Now logging is also good practice. So since we are using our local terminal, so we will do the logging is as just printing. So just simple as that. So we can say that backend server is running at port, then pass in the value of port, and then we can have this. Cool. So after this, now we will have to listen all the things that our port gets. So now while true, we will have to create a client so that we can accept a new connection from the client. So for that we need to create a client socket. So client socket and client address. So address is basically the IP address, and that will be the socket. So this will be server socket dot accept, and then this will be, and then since we have accepted the client socket and the client address, and then we will go ahead and we will receive the request from the client. So we can have request data that the client sent, and that would be client socket dot, this is basically the way we receive data, which is encoded, and then we have to decode that data. So with decode function, then we can go ahead and put a logging statement, log in the request data, because logging in a request data is a very good practice, so that you can always go back and see that what during debugging what request came, what happened with the request. So we can log in the request data. For logging the request data, you can go ahead and do a print, and then received request from, this will be here, and then client socket dot get peer name. This is the function that would give you the receive request. Post that, we can also, this is basically this peer name would give you received the request from which port or from where the request was received. You can also print in the request data. After that, you can have your response set. So response can be http. So response has a so response would contain a header as well as a response would contain a body. So this 200 OK would be there in my header, and this rn basically this is what differentiates from the body and the header. So you have to put this if you want a separate body and header. And in body I would give hello from backend server that issue created at port, and you can pass in the port value. So here we can have a port, and this is our response created. Then what we can do is we can go ahead and client socket dot send all is the method where you can send the response. And after sending the response, it is a good practice to close the client socket or the connection. So what we can do is that client socket dot close. So this is a basic code for starting a server and then running a server. So I would go ahead and run this program for you. So here is the run. Okay, I missed a double equal to sign. Okay, so let's start. So let's run our program once again. So see, we have backend server is listening to port 8081. We can have localhost 8081 hit again, and see, this is our hello from backend server which we should create. We can also go ahead and see the inspect elements here, and in the elements we can see networks tab, and when we try to reload this page, this goes to localhost. This is our localhost 8081 that the requested URL went to. 200 OK was the response from the backend, and in the response body we can see that hello from backend server which Rishu created is here, and this was the 200 OK and hello from backend server, and this one 200 OK was our response type which we saw here in the headers. That was status code basically. And after that we have http 1.1 was the type of request that we sent, and this is how we start a local server from our backend. And here when you will see in the request data which we printed, you can see that all the details are here. Let me zoom in here. So it was an http 1.1 get localhost 8081 connection was kept alive. Also this was the we also received request from here which we had printed here, received request from. This is our IP address, and this is, and then we have also received request, connection alive, all these things. And then we also printed the request data. So this is our request data. And so yeah, that's how you run a local server. In the next video we will talk about how, and we would see how we would take care of multi-threading in Python and create multiple servers on different threads. So yeah, until then, keep learning. Thanks a lot for watching my video. Please do subscribe to my channel, it motivates me a lot. And I will drop in my LinkedIn URL. You can connect me over LinkedIn and we can have more discussions there. Also in the comment section, feel free to comment whatever you feel about this video, what can be improved. do give a like and a thumbs up. So yeah, that's it. Thank you. Bye bye.